And hello, everybody. We are back for season 4, episode 4 of Code Live Google Cloud. I am still Aaron Wanjala, Java developer advocate, and I am joined by my amazing colleague Gleb, um, who is the database advocate for a very database related topic. We're going to be connecting AlloyDB to a model on GKE. Is that right, Gleb? I'm not actually sure what else we'll be doing, so I'll be learning along with you for the rest.
Right. So what we are going to do, we are going to deploy one of the model, Gemma, to GKE. And then we are going to create AlloyDB Omni, because the use case here, if you have AlloyDB in the cloud, it makes sense to use Vertex AI as a platform because it has all availability, all whistles and bells inside. So your model, probably the best place is to put it there. But if you want, or if you have some restrictions and cannot work with public cloud because of different requirements, it can be the just physical isolation from cloud or anything else. So what you usually have, you have a database, and the database has to use might need to use some ML models or AI or anything else. And then what you do, you deploy the local model next to your database and connect to each other. And what we are considering as a good architecture is use Kubernetes cluster for that. So it is exactly that use case we're going to explore here.
Fantastic. And if you're like me, I'm much more of an app dev. I'm experienced in that, but I'm kind of functional with like the database setup and infra. But I have worked in like PCI compliant orgs that have specific like networking requirements, maybe data sovereignty requirements. So this seems like a fascinating area to dig into, and I'm excited to do it. So yeah, take us away.
Yeah. So let me share my screen. What I did, what I started from, let me add to the stage. Yeah. I hope you can see my screen right now. So
it's pretty good. Maybe we can zoom in a little bit more, but it's...
let me do that. Right. Let me make it bigger here and zoom a little bit.
Perfect.
All right. So I went ahead and created the cluster. Not waste time right now during the event to wait in 10 minutes when the cluster is creating. And what I did, I created a cluster. It is a standard cluster, nothing special. And I added a pool with GPU node. And that pool will serve as a platform for our ML inference model. So what I'm using here is I'm using the just standard Google documentation where everything is step by step. You're going through deploying the cluster pool, and now we are going to create. So the pool is deployed. We have already pool. So now let's get credentials for the cluster. It is a brand new project. Nothing was deployed here before. So everything is going from scratch. All right. And let's work. Let's create a secret for, because to deploy Gemma model, I'm using Hugging Face, and I created Hugging Face token, exported it as a variable. Now we are going to use it to create Kubernetes secret to use that Hugging Face interface to deploy the model inside cluster.
Sounds good.
So, yeah.
So I already have a question. And of course, if you're in the audience, feel free to ask questions as we go. We encourage it. So yeah, you created an entry for VLLM. So did you just create the serving engine, or was that already part of the, like one of the nodes you already had deployed?
No, not yet. Nothing is deployed so far. So far what I created a cluster itself, and I created a node pool with L4 NVIDIA accelerator. Okay. That's it. So nothing else is created. What I'm doing right now, I'm going to deploy the model. So we created a secret with Hugging Face token. And now we are going to deploy the Gemma 2B model to the cluster. Okay. And to deploy, we need to create a YAML file. So we have, you can see we have example YAML file. And I'm not going to even change anything here. I'm just going to copy and paste to my file. Let's say vi my Gemma deployment.
Okay, and now I'm seeing the reason why it says kubeconfig entry generated for VLLM is because the cluster is named VLLM, right?
Oh yeah, it is
Okay,
just
that
I
makes
created
sense.
a cluster with the same name,
Right.
and
Okay. So
I
these are
I was not invented here because it is the name actually in the documentation. So I just copy and paste.
perfect.
So I just use VI to create YAML file. And what I'm doing right now, I'm just going to run the command to just apply that file. Uh, of course, it is different file name. It is kubectl. Apply
Of your
file.
actual file name.
Yeah,
And interestingly, in the docs, we recommend a file name that's like the name of the model, which has like 2bit at the end.
yeah.
If folks in the audience didn't know, IT stands for inference trained, right?
Yes,
Um, and so, or inference tuned, maybe. And so if it's a pre-trained version of the model, in case you're trying to pick between different versions, unless you're planning on finding your own model, go ahead and use the IT ones because they're just a little better tuned for general use.
good point. Great point. Yes. If you want to use out of box the model without fine tuning, yes, IT it is what you use. But I would say so. The Gemma model is going to be deployed right now, so we have to wait for a while. What I would point, if you want to fine tune model, yes, you can use non-IT, but in reality, it depends on how you're going to use the model, right? If you still want to use inference after fine tuning, I would use IT model as a basis for fine tuning as well.
Okay. Interesting. But if you're planning on doing a different kind of tuning, then you would use the base model and then tune it
That's
yourself.
right. Yes,
Okay.
because if you don't plan to use for like general purpose inference, then probably you might do it a little bit different and just take the base model and tune it by yourself.
That's a fair distinction. And we have a question in the chat here from KT Cobra. May he know what, or may they know what the spec in the YAML file is? Yeah, absolutely. We actually just copied it from the docs.
Yeah, here the specs on the file. You can see exactly what it says.
So we have it's one replica of a Gemma server, one replica of the inference server. So it's a fairly standard deployment of one of our open models, Gemma. 2bit, Gemma 2, the 2B size of 2 billion, is that 2 billion tokens? Or
No, it is 2 billion parameters.
2 billion parameters, yes.
Yeah.
And then it is inference tuned. So
yeah. And parameters, it is all together. It is biases and weights together. When you train the model, you specify a number of layers, and each layer you have number of weights, and you add the biases on that, and then you have all together. It complies to 2 billion parameters.
okay, yeah, fair enough. Yeah, anything else you want to ask about, please feel free to chime into the chat. The model is deploying right now. We could check how that's going, but yeah,
while it is deploying, also we can actually, what we can do to do not miss when it is deployed. So we can run command kubectl wait, and when it is deployed, it will return console to us. But what we are going to do the next, we are going, of course, to test the model if it works, and then we are going to deploy AlloyDB Omni. And I want to deploy AlloyDB Omni on just compute engine. So I will probably go ahead and create a compute engine machine for my AlloyDB Omni.
that makes sense.
Yeah, because it will take some time as well. Where is my
Yeah, to provision. And so you're choosing to just deploy it on bare metal just because AlloyDB Omni doesn't need anything else, or just for maximum portability?
AlloyDB Omni can be deployed on any Linux, really,
Right.
or it can be deployed on your laptop in reality. So it doesn't require Google environment or anything Google provided. What it requires is container engine, because it is deployed as a container. So
Right.
I'm going to go through the steps. So when the machine is created, let's create instance. It is going to be instance, let's call it AlloyDB Omni. And we have US Central and machine configuration. Let me open a little bit. I'm going to use E2 standard.
Sounds good. And if people are familiar with the E2 family of machines, an E2 Standard 2 is a little bit smaller than a MacBook. An E2 Standard 4 is about the same specs as like a MacBook Pro. 8 vCPU, that's a rough calculation, but it's 16 gigs of RAM on the 4, 8 on the 2. So it's not a huge machine size. Just to give a weight class of the machines we're talking about here.
Yeah, and I'm increasing the disk size just to 20 gigabytes, just to have some breathing room to install Docker and everything else. Not big, but enough. I don't plan to change any other settings. I don't think we need to change anything else. So I push create, and it will be, while it is creating, the next step, what I need for AlloyDB Omni is the Docker compatible environment. Or what I'm going to use, I'm going to use just Docker IO package. I'm lazy. I'm not going to install from scratch or
That's
doing
fair.
something elaborate here. I'm going to go to another window.
And I like this approach because it shows how little is actually required. If you're perhaps like an embedded systems engineer, you know how much is required at minimum to run something like this.
AlloyDB Omni.
And it's actually pretty relevant to how AlloyDB is used in general, because a lot of our defaults for AlloyDB are very like closed network, safe by default. And so you'll be setting up a lot of your own requirements for networking in most cases anyways.
Yeah, it is quite standard. When you go to AlloyDB documentation, and we are going to check the AlloyDB documentation pretty soon, but when you go to AlloyDB documentation, it should provide quick start, what we are going to use probably, but also it provides, let me actually find the documentation here. AlloyDB Omni install, yeah. So it is quick start, how you do that, but on Linux or Mac OS, but also it has how to set it up for production. And of course, it has much more steps and everything else, what is the best practice. But we are not going to do too much here. We are going to just install. So we have some requirements. It is how much RAM you need. It is 2 gigabytes of RAM, and we have some how to run it in Docker, right? So what I'm going to do, I'm going to install a couple of packages, and let me run it. Okay, sudo apt get install. I'm going to install Docker IO package, and I'm going to install Postgres client, because AlloyDB Omni is Postgres compatible database.
Yes,
the same interface, the same tools you can use. So,
and even the languages, it's a superset. If anything is added to AlloyDB, it's all, well, anything that is valid Postgres is valid Alloy as well. That tracks. And so at this point, we just have a base Debian image, I'm assuming.
Yeah.
And
I think it is 12 bookworm by default. Everything is default. I don't really install any other packages and just getting everything from scratch.
Yeah, talk about portability. You could definitely do this on any other cloud if you wanted.
Oh yeah, yeah. And you can use another Kubernetes as well, but GKE is just convenient to use. It's really good. So next, let's add myself GBus. What I'm doing, I'm adding myself web Docker to Docker group. Oh, of course, denied.
Super user, yeah, that makes sense.
Yeah. All right, and I'm going to reconnect. All right, so next steps, I'm going to install the AlloyDB. So how are we doing, by the way, on our, oh, it is here. So let's check the logs, because what we need, the deployment itself is one part, but we also need to check that the interface is running. Yes, the main thing is here, the application itself. It is VLLM application, which is served as a API, external API for the model itself. So we deploy the model, but to access the model, we have to have some kind of API running on the server. So that is UVcorn from Python is running on port 8000 here. So how we can test it? We have actually, we can port forward. So first we can see what kind of services we have. So that LLM service is a cluster IP service. And if you have a look to our YAML file specification, it is what we installed here. So it is accessible only inside the cluster.
Inside, yep.
Yeah, so to make it accessible not only inside the cluster, what I'm going to do, I'm going to create a load balancer service.
Makes sense.
Right, let me, my Gemma service. I just copied the same. It is going to be ext.
The external service, yeah. So
LLM service, and then instead of cluster IP, we put load balancer here.
Yeah, and if folks are somewhat new to Kubernetes, this is how you make a service external. Having a load balancer as an external service will distribute requests from outside the cluster into a specific port on a specific container as defined by that spec. And
my Gemma service.
I think we have an equals F there instead of a dash.
But, oh yeah, sorry. Yeah, thank you.
No worries. And
all right, and now we need to wait when it is. You can see the external IP is still pending. So in meanwhile, we are going to go forward and continue to work with our AlloyDB, because it takes some probably like 2, 3, up to 5 minutes to get that external IP.
Yeah. So to this point, we have our DB, the VM that's going to be running our DB is set up. It's running Alloy Omni already. We have our user created. That's fantastic. And then we have our inference server, which is actually going to be like we've deployed the model to our, with our Gemma container from the docs here. And now we're going to be connecting the two, right? Or if I jump over.
So first, yes, we deployed the Gemma. Gemma is supposed to work as soon as service is up. I'm going to test it. I'm going to test using curl utility. It is easy. You go to the API endpoint and get the result. But we haven't created the AlloyDB Omni itself, so
Oh,
we need to deploy it. So what I'm doing right now, I'm deploying the AlloyDB Omni. So what I'm doing, I'm running Docker run. I define name for my AlloyDB Omni container. Then I create a password, and of course it is going to be very strong password,
yes.
very strong password. It is exactly how you do that, right?
Fair enough.
Yeah, nobody can. And then technically, I need to define that what kind of image I'm going to use, right? But before doing that, what I want also, I want to expose a port 5432.
Default Postgres port.
50, that's right. Because what I want, I don't want to go to Docker container to connect to the and work with it. I want to use my locally installed already Postgres SQL client on that particular VM.
Fair enough.
And it is image, and it is how we do that.
Fair
So
enough.
it will take some time to download the image and install everything. So first it download, then extract and everything else. So in meanwhile, let's have a look what our service is doing.
Yeah.
Oh, we have it. Yeah, we have it.
Perfect. We have our external IP.
Yeah. And how we can test it, it is actually in documentation as well.
Excellent.
So it is user prompt equal. It is not really interesting prompt, but that's all right. It will work. So user prompt is I'm new to coding. If you could only recommend one programming language to start with, what would it be and why? Aaron, what is your guess?
Well, I'm going to say JavaScript because it can kind of do everything.
All right, we're gonna see what Gemma 2B thinks about it, right?
Yeah. It's an interesting question. I would answer it with a question in the real world, but
yes. What you gonna do with that, right?
yeah. And to those at home who may be wondering, have we just exposed an AlloyDB cluster to you? Not quite, because the service has an external IP, but our AlloyDB cluster is only available within the cloud, right? We only have...
That's right, yes. AlloyDB is not available to anything. It is just locally on that VM, and it is inside private IP. It doesn't have any... The VM itself has a public IP for SSH connection only, nothing else.
Yeah. And that kubectl command SSH, under the hood, it does a lot of connection for us. It sets up a secure tunnel for it. But yeah, interesting side note.
Yeah. All right. Let's try. And
handy curl command to everything. Yeah. It may not have picked up the end of file there.
It could be, yeah.
We may actually be missing. I think we're missing a backslash at the end of the third line to continue the end of file tag. So it thinks it's
really?
Yeah.
I'm not sure about that.
I don't know, because we have at the end of the -h line, we have a backslash, but not on the others.
Let me try a different way. Generate.
Good old single line conversion.
Yeah. Yes, and I would say if we put it to single line, I'm not sure. I don't remember the syntax actually. If we create like prompt,
I think we'll be okay. I don't think you'll have to escape any characters. I think it'll.
Yeah, and I'm not going to put any other parameters right now.
Fair
I'm
enough.
just put the prompt.
And all those other parameters are optional anyways. They have defaults, and I think those are the defaults for temperature, top beat, and
Yeah,
everything.
I think so. I'm not getting any response actually. That's interesting. I
Hmm.
should have some.
Yeah.
Oh, I know why.
Is it?
Of course, of course, of course, I know why. Because I didn't specify the port.
Oh, yep.
It
5432.
is,
So it was
yeah, it
it was
is
it was
8,000.
trying it was trying several times and about to time out if we'd given it about a minute, I guess.
Yeah.
There we go.
Oh, it is
So
block
I'm
loaded.
guessing the first one would have worked. Yeah.
Yeah, I think it is just, I don't remember all the, all right. Okay. Oh, yeah.
There it is.
So Python.
Python. Okay, interesting.
Yeah. So Gemma 2B thinks if you start right now, you have to learn Python. I'm not sure if I agree with it, but
Yeah, well,
that's AI opinion.
you
So
heard it here first. That's what AI thinks is the best language to learn.
yeah,
And it was started originally as I believe it was started as a language to teach kids how to code, and then it needed like a security feature, so it just grew and grew and grew. And so it's supposed to be easy to learn. It's not the worst answer.
yeah.
Interesting.
All
Okay,
right. So let's go back and see. Oh, we have already database. So
excellent.
Docker PS. Oh,
Excellent. So we've pulled down our Docker image for Alloy. Um,
here
we have Gemma
every.
actually running. We've already done a request to it.
Let's connect localhost. Very strong password. All right, we have default databases. So let's create a database. Create database demo
Perfect.
and connect to that database.
And as more of an app dev, I spend most of my time working with pSQL, asking Gemini to give me the pSQL.
Right.
It works pretty good, actually.
Yeah, it does. So we have database demo. Let's check what kind of extension is available. For us is Google ML integration extension. That is what we are going to work with. So let's go to documentation right now. So we have Gemma on GKE. It is served on port 8000, and we should be able to connect from the database using Google ML integration and run the queries which is using the Gemma on GKE inside database. To make it happen, we need to do some configuration on the AlloyDB side.
Interesting. So what you're saying is that because we downloaded that version of AlloyDB Omni, or so maybe this is all versions of AlloyDB, it comes with that integration already installed.
It comes with the integration install. It is we download the default version. It is not special version of AlloyDB Omni. It comes with already some integration installed. What it doesn't have integration with our model. So,
Right.
and we need to enable that that property of the database to be able to register. By default, it comes with configuration to use Vertex AI,
Right. But
but
since
we are not going to use Vertex AI.
yeah, and actually maybe that's something we should have called out at the start. If it's not clear to people the difference between Vertex and our Gemini models and Gemma, our open models, it's that these are open source, open core models. You're able to fully see the source and deploy it yourself and have control over all of that. Whereas Gemini is less open. And so if you need that control, if you want to make choices about it, or you just need a guarantee that everything is happening the way you expect it to be happening, this makes a lot of sense. And I didn't know that you'd have to have another step to configure use of Gemma for this. So that's interesting. I'm excited to see.
So it is not only about Gemma, it is about any kind of model outside the default model coming out of the box.
Interesting.
So, and it could be Gemma, it could be fine-tuned model, because when you do fine-tuning, you deploy it either on Vertex-AI. In that case, you still need to register it because
Okay.
it is not coming out of the box. And or you deploy it on GKE, and it could be Gemma or any other models you create, you deploy, you fine tune, or whatever, and then that model we need to register inside, and it makes sense. The database has to know where the endpoint for that model, what kind of authentication you have, what kind of API you expected, right? So that's what we are doing here.
Makes a
So,
lot of sense.
and we have the documentation here. Let me find it out. Monitor, connect, just, oh yes, here. And build generative AI application using AlloyDB. And here we how to work with vectors. We are not touching vectors today. We are going to work with Gemma, which is not embedding the model, but it doesn't mean you cannot use embedding models. You just
Right.
need to deploy it on GKE. And how we call models using model endpoint. So, and let's go and register model. So first, what we need to check is Google ML integration enable model support. All right. All right. So we are going here and doing that step. It is exactly what we need. And I'm just copying and pasting. And we can show Google integration. Let's check the parameter. It is on, great. So then we have documentation about authentication, but since we deployed Gemma on GKE cluster, it doesn't have any authentication requirements.
Right.
We don't need to worry about that. We are not working with text embedding models. So let's go forward. We are working with generic models. So it is exactly what we need. We don't need a secret for, because if you, for example, decide to use model on Hugging Face, you have to deploy the token, right?
Right.
But here our model doesn't have any requirements for token. It is additional layer you might introduce in your environment, but it is not what we are doing right now. But if you have authentication, you can use different ways how to store your secrets. Here the example with Google Secret Manager, but it doesn't mean you have to use Google Secret Manager. Probably, I don't really know. It depends probably how you enable authentication itself. It can be part of your call to the model
As a bearer
itself.
token?
Yeah.
Yeah, I imagine that bearer token authentication will be supported, and probably the Kubernetes secret as well. But we heard last episode actually from Caslin that the Kubernetes secret authentication is not quite as secure as
Yes.
like an external secret store.
Yeah.
So I think it's a good thing that we're surfacing the secret managers or recommended authentication path. If you have
That's right. Yes, Kubernetes secret is not a secret really.
Yeah.
And everybody who works with Kubernetes knows that Kubernetes secret used primarily right now not to store any secret password or anything else, but store configuration information.
Right. Okay. Just as a generic key value store, really.
That's right. Yes. So let me copy that part, and I need to modify the model ID will be my Gemma. I will need to change model provider and request URL. We are going to use from here.
And so if you were using a deployed model, this would be the model endpoint, right?
Yeah.
But instead, because we have our model running locally, we are just going to use that endpoint. The external
Yeah,
The
it is exactly
yeah.
what we're going to use. HTTP to our API generate request. So that is, we can put this optional my Gemma. It is not my Gemma, it is my Gemma here.
Yeah.
And it is what we actually need. And here it should be custom. Let me copy and paste to my environment and correct it. Just right, because I'm not calling the Hugging Face, it is custom. Model type is generic.
And is that like a specific enum, or can we just put generic in plain text?
No, just generic.
Yeah, okay, fair.
Right, I think. Let's try it. So I just slightly modified it. Oh, you're gonna see it here. What I created. So I put it ID as my Gemma. This model provider custom. This URL. I don't think model qualified name is not really. We can omit.
I'm
It is not
assuming that's
required.
just used as like service discovery if it's trying to use a domain name resolution within the cluster.
Yes, if you have endpoint for primarily it is used for text embeddings. When you have endpoint, it is going to the endpoint for out of box and embedding model, and based on model qualified name, choose the exact model you want. Because model endpoint in that case might not include it is just include broad API where all embedding models are served with the same API syntax and everything else, but exact version of model is defined by model qualified name. This is how
sense.
I remember that.
So in our use case, it's not relevant, but it would be if there's more to select from.
Yeah.
That makes sense.
Right, it is done.
And
so
that,
what?
yeah.
Question?
No, I'm just like, so that we just actually called the model, or
it is call. It is create. Create.
Okay, so we created the function to create. No, we just created the model.
No, so to create a stored procedure.
Yeah.
Inside, to not create. To use store procedure inside Postgres, you use a call.
Yeah.
With function, for example, which returns some value, you can use select function name parameters, right? When you don't expect any output from the procedure, this stored procedure, which we provide all the stuff, but we don't expect anything from that, right?
Fair. Yeah.
We just call it, and it is creating a registration for that model inside database. So now we can use it.
Yeah, I'm curious, what kind of use cases does this enable? Are we able to like use this within a join, or can we just kind of like tag this onto another request to?
We can just select from the model. We have a function. So in the documentation, let me go to documentation, invoke predictions here. So we have functions Google ML predict role. And here we can provide our request body. And for example, our request body can be used from here as well. The same exactly request body like prompt and let me put it the same way. Okay, prompt.
And we can pass in parameters, the exact same syntax.
Yeah, exactly. It is what we supply the same like body in our URL request. So and the best programming for data scientist. So I think, Aaron, you can have a very educated guess here.
Yep, I think there's maybe two answers. It would be either R or Python.
Let's have a look.
Judging by the last answer, I'm kind of expecting Python again. Which, isn't it curious that an ML model would return Python as the answer for the best programming language?
Let's see if it works. I don't think it does, actually. We probably missed something, and it is quite possible.
Could be.
Yes, let's. We need to wait timeout. I believe it is timeout. It is not going to the model. So here we put the proper address, we put proper port.
Are we able to request by the model request URL rather than the ID, or is it always by the model ID?
Oh, hold on. Here the failed to connect, but it is connecting to local host port 1000.
10,000, yeah. Failed to
Oh,
connect.
10,000, right. Let me check documentation just really quick.
Yeah. Failed to connect to remote host is interesting. I wonder if it's failing to reach the endpoint that it's trying to reach out to.
Hold on. Install AlloyDB Omni with AlloyDB AI.
Interesting.
Let's go there and see if we missed any of the steps.
Yeah.
That's not relevant here at all.
No, we shouldn't need that. Private key, we're okay.
It is. Private key is relevant only if you have authentication.
Right.
But that's actually can be the thing. Omni enable ML agent process.
Interesting. There's you need the ML agent process for.
Yes, and I'm not sure if it is here. Let's show. It is off.
It is off. Okay.
Right. So we need to enable it. Docker exec ti my omni bash.
Just opening up an interactive shell, and so.
Yes, I need to change the parameter in PostgreSQL conf file.
Right. And then will we have to bounce the installation, or will it be able to change?
We need to bounce it.
Fair enough.
Right. I think it is here. What data? All right. All right. It is here. Let's check. Oh, it is not here. So let's.
Would we have to cat the output of the file before we can grep it, or is that valid?
I don't think we need.
Don't think so.
Yeah, but
okay.
But if you grep it, it should provide output.
Yeah, I guess I just never usually pass file names to grep, but I think that does seem
right.
There we
now
go.
It is here. Yeah.
So that's mystery solved.
Yeah. All right. Docker stop my omni. Docker start.
Simple as that.
Yeah. So let's connect. Hold on. All right. Okay, it is on, and we
Okay. So it
what exactly?
seems
Something is not right.
raise error if model does not exist text. Okay, so it doesn't like the model ID you were sending in?
Oh, hold on. I didn't. Yes, of course it is. It is kind of silly. We should have model ID in our request.
Oh,
No, it is my Gemma here, right?
yeah, we do have that.
Did they register? Yes, it is my Gemma.
Yeah, model not found for model ID my Gemma. Interesting.
Yeah, it is interesting. Select.
And it wouldn't like transparently change the case on a dash.
No, I don't think so. Right. Let me. This we need to check.
And this is the interesting part that we tune in for here. We want to see, some aspect of thinking through it live. So I am grateful for this challenge here.
We did register the model, right? We have.
So I'm seeing model underscore ID, and then do I see model dash ID in some places? Did
No, we
hallucinate?
have dash here. Well, I don't think we had anything else.
Okay,
Let
yeah.
me- Oh, hold on. I'm trying to find out if we missed something.
Mhm.
It should be there. Let me go to the reference and check the model. All right, and secrets. Let's try list model here and see if it works. That's strange.
Yeah.
Let's try. Let me try. Oh, of course. It is silly of me.
The database we were using.
That's right. Yes.
Yeah, we
Oh,
didn't we
so
didn't choose the database, right?
yes.
That would do
Oh,
it.
yeah. Okay. So, what is the best? As it depends on, and then you have to go. Probably we just return only first chunk. So
Yeah.
to return all the other chunks, we probably need to combine them together. But the main idea, it is answering the question. We can research. Do we have time to research how
Yeah.
we can get all the chunks?
Yeah,
Let's have a
absolutely.
look.
I think we have another, half hour at least, and
Oh, good, great. Yeah.
we've
Another way,
already
yeah. So we deployed the model on VM, but actually, not model, AlloyDB only on VM, but actually, where we can deploy it is inside the same cluster.
okay. Yeah.
In that case, none of the calls is going outside. It is everything inside cluster.
Still all cluster local, yeah.
Yeah. So the first, let's have a look at how we can get the predictions, all the chunks, because I believe we are getting only first chunk.
That tracks to me.
Yeah.
And thank you, Mark. It is always the little things that trip us up, but hey, it's good to figure it out live. And also, Gleb, I'm curious, why is that
Yeah.
chunk so small? Like that looks like less than 100 certainly less than 100 words. It's like maybe 150 characters.
I think it is how VLLM split. two different records output.
Fair enough.
I don't think it is related to how many tokens we specify or anything like that.
No, it seems too small to be token related, like
Yeah,
output or input token.
it
It
is
seems
just
too small.
first piece of chunk. I think it is two ways how it returns the data. Sometimes it returns it formatting as markdown, right?
Yeah.
And sometimes it is just split it to the chunks and return chunk by chunk. Here, what we are getting looks like we are getting only first chunk.
Yep. That makes sense.
And it is probably a JAMA interface, how it works. It is nothing to do with how we request the data.
Right. And nothing to do with Alloy. I was thinking as well.
No,
I know there's
I don't
some
think so.
details about how Alloy will work better at some like chunks of data, but that's not, this is much smaller than 2 kilobytes. So
yeah, it is just how you're getting request, you're getting some piece of information back. That's it. And I think it splits request to different chunks and returned as a list, and we are getting the first record from the list.
Interesting. Yeah. It looks like JSON array syntax. So
yeah.
Makes sense to me.
And I'm just thinking how we can get actually request all the body. Do we have anything in documentation? Let me check the guides.
We'd be able to pass another parameter. It's strange that predict row only returns one, and then there's
yes
multiple.
But it is how it works, right?
Yeah.
Where is it? To build, generate embeddings, invoke predictions, right?
And then I also want to talk a bit about efficiency once we've got more of the rows coming back.
Maybe we need to additional parameter. I need to read documentation for VLLM. I don't really know.
Yeah.
It is a good question, but it might go a little bit beyond what we are getting here.
That's totally fair. I do have a question on that efficiency side of things. I'm like, now that we've done what we set out to do. We connected AlloyDB Omni to our model, and so now we're actually running the model with the stored procedure on our instance running on the compute engine. Now, I'm trying to think of like in an architecture, when would I choose to do this rather than running it on like an app server? I'm guessing that maybe it's like when we want to do one round trip from the application to the backend service like a database, and then come back with several responses rather than having to do 3 or 4 and storing them. I'm not sure where the...
So the first case, for example, when you want to do it, you want to simplify your application.
Yeah. Okay.
In that case, for example, if you do semantic search using vector search, right? You have a table inside your database with all the vectors, right? And what you need to do in application, you need to get your request, go to model, create a vector, and then send vector as a parameter to the database to do semantic search.
Right. Back and forth a little bit.
Back and forth. And if your LLM deployed next to the database, for example, and you don't want to expose your LLM,
that makes sense.
It can be inside your secure zone where your data and LLM together. In that case, what you do, you just send that request directly to the database, and the database is doing conversion of your request to vector and doing the vector comparison. That one case.
Yeah.
Another case, it can be part of the store procedure inside the database. And that store procedure depending on the parameters. For example, you supply your transaction, financial transaction, and your fraud detection is working inside database. Your application is supplying the transaction and getting if the transaction is declined, accepted, or on hold, and that's it. And all the logic will be inside database, and that logic might include to call a local endpoint fine-tune model to understand whether the transaction can be fraud transaction, or it can be just out decline it right now, or it should be verified by a human later. So that's kind of logic behind that.
That's fair. Makes a lot of sense. Yeah, no, that is like the VPC angle of like having a gated area where you pass the request in, and then there's no need to exit that fence.
That's right.
That makes a lot of sense. Huh. Interesting. Yeah. Now
and also the vector store. So you know that your request has to use the same model as a vector, right?
Yes.
And I saw quite a few cases when people do not want to use vector models in the public space. They want to use vector models created by their own needs and fine-tuned and locally deployed. And there are quite a few reasons behind that.
Interesting.
I don't want to go deep down. Sometimes it is just simple cost.
Fair.
If you have like 200 million rows and try to use Vertex AI or OpenAI or any kind of Anthropic, for example, models, right?
Yep. Those
it will be extremely costly.
Yeah. Yeah.
And
that rate of a couple tenths of a thousandth of a cent really adds up when you have 200
And
million.
it is not only about the cost itself, it is also the response time, how many rows you can batch together, how many rows, for example, Vertex AI or OpenAI or any other provider, public provider accept for batch processing. So there are technological reasons, cost-related reasons, security reasons. You don't want to expose your data ever to any other public service providers.
That makes a lot of sense. And that's actually something I was kind of getting at when I asked about the efficiency. I'm like, wouldn't I be able to, in a lot of cases, like parallelize requests to a model like this if it's running somewhere else, like from my Java application? But honestly, being able to like this approach does make sense for cost reasons and for response time reasons in the way you described. Like it's going to depend what your actual org's needs are.
Yeah.
But it's good to know about this other approach.
And we have customers. We have customers who work with both variations. They want to work with local models for some cases and with public models for other cases. And the reason is quite simple. For example, Gemini is great for actual human response and everything else. It is a great model. And for other small cases, for example, if you have a RAG application,
Yes,
you have different stages when RAG works. The first, it is identify intent for your task, what kind of path you are going to take, whether you just can return back answer, or you need to call the database, or you need to call internet or anything else, right? The RAG is supplemental information from different sources. And to understand intent, you might to have just small database, small model deployed on your GKE cluster without going back and forth to Gemini, because it will be just faster from response point of time. Yeah. If you have local, very quick request to your GKE cluster with local model just to understand intent, it is going to be like microseconds, right? Milliseconds. And then you're going through different stages. You're going to database, everything else. And then finally, you probably want to use on the final stage Gemini to create that proper response to your client's application.
That makes a lot of sense. And I feel like there's a lot to be said. There's a lot to be written about how to trace and improve the performance of a multi-model response like that. When you're trying to route intelligently through different models at different places in your like networking stack, there is a lot to be said about that. So maybe that'll actually be a subject of future streams.
Yeah. So we still do we have time?
Yeah, we do. We still have a half hour.
Oh, right. So what I would like to do, yes, we can just try. I can spend half an hour talking or trying to get other chunks from the model. But what I would like to do, I would like to deploy the AlloyDB in the cluster and use not public load balancer public IP, but use cluster IP and see how it works.
Fair enough. And maybe we can compare the response times. Will there be a difference there?
I don't know really, but we can. Of course, we can. So we can just record what kind of response time we are getting right now.
It was pretty quick from what I remember. I'm going to guess like 110 milliseconds.
Timing on. I don't remember the syntax. Timing. Timing on. No. It is like set timing. I don't remember. I need to Google it really.
Don't we all? Slash timing, apparently.
Oh, slash timing. That's right. Timing. All right, and let's run that, and we're gonna.
Okay, 437 milliseconds. That's actually much longer than I thought.
Maybe it is because. No, hold on. Let's try again. Yeah, it is. It is about 436 milliseconds. But most interesting, it returns different lengths for the answer every time.
That is interesting.
Yes, it is like there is no one size fits, and that's yeah, it is. Right.
Yeah,
okay.
Different ways of saying the same thing. Fair enough.
So what we can do, we are going to go back to that particular shell, and let's try to deploy in the same cluster AlloyDB Omni. So, okay, install AlloyDB Omni on Kubernetes. All right. Helm. We need to add Cert Manager service here. Let's do that.
Sure. And I'm assuming there is already a Helm chart for AlloyDB Omni. So.
Yeah, I think so. Yes, it is here. But let's go step by step. Let's add the. Shouldn't take too much time. It is quite simple service. All right. Next, okay, we have to. Let's provide some variables. Everything is from documentation.
Yeah, it's a good test of the documentation as well. I see that we have GCS bucket. Do we actually require a GCS bucket for this?
I think so. It is where we are getting the Helm package.
Oh, okay.
Yeah, it is what we are getting, right?
Oh yeah, but it's creating the bucket for us. There we go.
It is copying from the bucket. It is public bucket.
Oh, there we go. That's what I was missing. It's one of those, like how we have public package repositories for.
Yep. It is we just copied that file. So now we installing the operator. Let's put the operator. Hopefully it will work. I don't really know.
No, I think that would be a bit of an event if the operators didn't work. But
I didn't read too much through requirements Probably I should, but it is how we learn.
That's okay. We'll find out if we meet
Yeah,
the requirements.
right. Right, it worked. So, but it is not the database yet. It is just operator which manage the database cluster in the database cluster inside GKE cluster. So now we are going to deploy it. Right, and of course we have this Red Hat. It's not really interesting. Create a database cluster. Oh, okay. So we need to create this. We need to create
the database cluster.
not only database cluster. We need to create a secret for database password.
Ah.
Because when I see, oh yeah, here, DB cluster name, it is going to be my Omni. And the encoded password, we can use base 64 for encoded password, right? Yep. Let's base 64. I think it is encode.
Encode, yeah.
Encode. No. Probably a couple of dashes. No. Let me check the help for base 64. I don't remember syntax.
You pipe it into base 64, or you can triple arrow it in.
Oh yeah.
Yeah.
Sure. Echo.
Yep.
64.
There
right. That is going to be our password. Right.
And we did miss an equal sign there at the end.
I don't think it is going to be a problem. We can put it.
Yeah, I don't know when it decodes.
I don't think it is going to count at all, but usually have only one.
Yeah, I think isn't equals in the character set? Is that this one of the 64 characters?
I don't remember.
Oh,
I don't. I will keep one. If it is not working, I will try to do something else, right? So, but again, CPU count. Let's put one CPU memory size. We used. Let's check what kind of nodes we have in default pool. Because what we don't want is
a difference in the size of the machine to
that's right, yes,
result in the response time difference. I think it was an E2 standard 2 with 8 gigs of RAM for the cluster, but I don't know what the node size was.
So we have available 6 gigabytes of memory.
Okay.
So let's put it.
And so that's 6 gigs available to the default pool, but would that be equivalent to this?
Yeah, it is going to default pool.
Okay, yeah.
Yeah, we can specify, of course, what kind of namespace pool and everything else, but I just don't want to. I want an easy way.
Right, so, fair enough.
Yeah, so let's put it 5 gigabytes and size.
20, yeah.
20. I think that should work, hopefully. Yeah. If it doesn't, we'll see. So let's create a YAML file. GKE cluster. Okay. And
now for those at home, that is a very decodable password. So, don't decode our very strong password and and share it publicly.
It is how you should do. It is very strong password. It is
Yes.
not just strong one.
Interesting.
Illegal base 64 data. So probably it is actually 2 lines.
It wanted to, and I'm not sure why it would have outputted 2 equal signs at the end, because that is the suffix character. You're supposed to have only 1 at the end, but it seems like it encoded some of the data as an equal sign, which is curious to me. But hey,
let's try. I don't know. Why it doesn't work?
Are you in insert mode?
Yes, I did. All right, now it works. Okay.
Weird.
Yeah. You were right.
I don't know why, but interesting.
Good. So now we need to check we can go easy and check workloads here, or we can go and see just kubectl command. But again, right.
Interesting. And
so what I want to use is K9S. Yes, I like it.
I also used to like K9s. I haven't been using it these days, but yeah. And I've never installed it on a Cloud Shell. I'm surprised it wouldn't come with Cloud Shell. So many of the tools I like using just come for free on Cloud Shell.
Yeah, but not that one.
I guess not this one.
The problem with installing this one is it's already here. Probably I installed some time ago.
Yeah, on one of your. There you go.
Yeah. Okay, it is pending. What is it?
Excellent. And if anybody is wondering in the chat, if you want to, place your guesses on which one is going to be faster, the cluster local one, or the one that we timed with the external load balancer at 436 milliseconds, or how much faster it'll be, if you think it'll be faster. It's unschedulable.
Insufficient CPU.
Do we want to set it to 8? Is that because the other one was set to 8 as the limit and then chose 6.3? I don't know.
I don't know. All right. So it is. Let me. How it can be insufficient CPU 1?
That is interesting, actually.
Yeah. It is 5 gigabytes, right?
Okay. Is it because, wild guess, is it because the machine that's running this whole, like the machine somebody chose for the whole thing was E2 standard 2, which had 2 vCPU, and then we're already using 1 and we're requesting a whole 1 as well?
Yeah, but it should work anyway.
I would have thought so, but
invalid. Let's check what we have here again on the nodes.
793. Seems fine.
Seems fine, yeah.
2.4. Yeah, I don't know. Oh, that's GPU though.
Yeah, so we can increase node pool. Technically, it is not big deal. I mean, hold on. So we can technically increase size for the default node pool, but it will take some time. It is like 5 minutes or so. We probably can't do that right now.
Yeah, and when you say size, do you mean memory size or the CPU?
No, just shape. Provide different shape for the machine, right?
Fair. wonder. Hmm. Yeah, I'm curious about that 436 milliseconds. I'm trying to think of what else could account for that. Um, does the timing, is there any way to break down timing to say, like, this is how much it took for the request to complete on the installation, and then this is how much it took to return to you? I wonder.
I don't really know. Okay, right. I'm trying to find out how the syntax of updating the pool using gcloud.
Yeah.
Okay, gcloud.
Well, I'm, I'm also seeing, I'm wondering if that timing command took into account the amount of time taken to send that, like to actually hit enter on that command.
You know what can be a problem also? We had E2 standard 2 or E2 standard 1?
E2 standard 2.
Let's go to E2 standard 4, right?
Yeah, so that would be 4 vCPU, and 16 gigs of RAM rather than 2 and 8.
Yeah, let's just in case. Yeah, it is complaining, so let's put it here. Update default pool. E2 standard 4. Let's do that.
Makes
It could be the problem also with the disk space. I don't remember what kind of disk space we have. Let me check.
Well, actually, you know what? Wow, that wouldn't make sense. But doesn't a model like Gemma? I'm not sure about that size with 2 billion parameters, but isn't the model like 50 gigs in size?
I think so. It is not small one.
Yeah, or maybe it's 5.
But now we're hitting the problem not with the model, and actually the model is deployed in different pool.
Right. Yeah.
Yeah. So that is not related to that part.
Right.
It is related to our problem with when we go here to workloads, for example, we can see clearly that it cannot schedule all what it wants.
It's for CPU and memory.
Yes.
And it's also hoping that a GPU accelerator is present, which the E2 family, can you request GPU accelerators with the E2 family?
No, it is not. No.
Okay, yeah.
And we have different pool for it is G type G type node for L4 accelerator.
Fair enough. But we shouldn't need an accelerator for this generic model. Right? Maybe we
Technically, you actually can work. It is going to be really slow, but you can. I tried. And here we have less than half a second, right?
Right.
For request. And just keep in mind that it has to do through different layers. It is different layer of parsing request in the memory of the Postgres server, creating request, doing some function call behind the scenes using the extension, which is written probably on Go language, for example, and that Go language call will go to model, then return back, and then return back to our Postgres interface. So, and the model itself have to parse your request. It is going through tokens and everything else, then generate a response, generate those tokens. It is encoding, decoding part. So it is quite a lot of stuff involved. So from my point of view, 400 milliseconds is not a bad result.
That's fair. That's fair. It's not a terrible time. Certainly won't be killing your request time if you're looking to trace something down.
Yeah. But if you work with, for example, Gemini application, what kind of request you are getting? for your question?
I'm not sure. What do you mean? What kind of request? Like,
What kind of latency for request? Is it
oh,
last
it's
half a
it's
second?
it's more than 400 milliseconds. It's
That's much more than
yeah
100 milliseconds.
yeah
For example, I was talking on one event about the difference for long context window and everything else. For example, for long context window, if your prompt is close to, for example, 2 million tokens, your answer, your request, like latency for your request, it can take up to 45 seconds to get response.
yeah. In the first episode of last season, we had Jason come on and we did some like limit testing with the token limit, and we did have some requests that took over a minute to respond when we were getting there. Also, yeah, I see somebody in the audience, Aptly Art or Artie. Hello. If you have any questions, feel free to shout them out. We are experimenting with the difference between a model that's deployed cluster local and one that is like inside of the same cloud project but running on compute engine, and seeing if there's any difference in the response time between the two. I'm not sure if there will be one. But I do want to see the answer, because we got 436 milliseconds with the VMware call from our cluster, and so I want to see if there's any time savings without having to exit the cluster.
It is actually running.
It's running
already. Yeah. So it is already running. That's great.
So it was something between the disk size and the CPU. And
I don't know. Let's refresh here. Oh, everything is up and running.
All right.
Probably something is already updated. And probably the memory was really tight.
Yeah, I can see that.
Yeah. So it is running. So what we can do, we can go inside and try to register now how we, right.
So we have to create a separate stored procedure for our second.
Exactly. We have to go through the same steps, really.
Yeah.
Nothing different. So let me.
And yeah, I've never. While you're doing this, I've never. Just thinking about it, I've called these models programmatically with the straight client libraries and also through frameworks like LangChain. I've never created a stored procedure programmatically, but you could, theoretically, you could want to create a stored procedure with like a batch job, and then be able to hit it for like a reporting use case. So that makes, I should look into how that's done, actually. I don't know if any of the frameworks support that yet.
So, all right. Let's try to connect. Very strong password. No.
Not interested, huh? Do you need the port specified? 5432? No, it does have.
No. It is password authentication failed.
DB pod? Yeah.
No, it is something wrong.
-c database, is that specifying? Because sometimes Postgres conflates the database and the user, right?
No, it is something we did when we did like base 64 for the password. Something was probably not right. Secret. So it is calling the secret and getting the data, but
yeah, password authentication failed. Yeah.
Yeah, it does. I need to check the secret. Do you remember how to check the secret? It is not the secret really. It is.
Are we looking for the encoded version of that password?
We want to get the data back from the secret.
Yeah. I don't remember the syntax. It'd be
kubectl. Let me check it out.
list secret. Get secret. I think it would even still be in our like terminal history there.
No, it is decoding Kubernetes. What the secret name is?
The secret name.
Right. Just let me check.
Yeah.
kubectl get secret. So the
dbpw my omni.
That one, yes. kubectl. I think it should be get secrets, and then all right. But let me check the documentation what we used for install. Where is secret? Metadata name. All right. Data my omni, right?
Oh, okay.
Yeah, okay. Right. We need to get secret dbpv. I think omni. Then template data, and it is gonna be my omni.
Yeah.
Right.
Interesting.
My omni.
And
then we are going to decode it using base 64.
Bad character.
Bad character. Oh. All right. That's too bad.
Yeah, interesting.
I'm not sure if we can change the password now, but it would be interesting.
Yeah, well, I mean, I'm wondering if it's not expecting dashes in that context. Did it?
Yeah, it is. It is something we with that particular context, like with dashes and everything else. How to? Right, kubectl. Let's go to the server itself. Let me go to the server itself.
Yeah.
I mean, inside the pod to the container itself. All right. Okay. Kubernetes.
Interesting.
Database port. Yeah, it is what we're going to do. Right.
Apparently, you can pass in you can escape the dash with quotes.
Hold on. SQL host. No, it is not working with that. What do you mean?
Yeah, so I sent you in the chat. I have a DB secret. So when you're doing the template, you can apparently just have like .data and then space it and then in quotes like my dash.
What chat?
In the stream platform chat here.
Oh, okay. We have
Yeah,
chat here.
yeah. There's a
Oh,
private
okay.
chat there, and or I can actually send you it on a different chat there. And
I I'm not sure,
I wonder,
uh, but hold on. It's just different syntax, right?
yeah, it seems to be complaining about. I think that template error was talking about like the dash in the variable we're trying to access in the template.
I'm not sure if it is actually valid value itself.
You know, like some of the my omni value,
No, it is not my Omni. Oh, hold on.
we're in the machine, yeah.
Get
So
secrets. You mean in template?
yeah, inside the template, if we replace dot my omni with space and then in quotes my omni, still with the dash, it'll apparently resolve.
Hold on, hold on. Did you try?
I did not try it, but
I'm not sure where should I put it, dash.
okay. So yeah,
Can you tell me?
yeah, with if you go back to the like within the template, the double curly braces.
Yeah, yeah,
So we backspace remove the dot there, and then just the second dot after dot data.
yeah.
So then it'll be instead of dot my omni, it'll be space and then open double quote
And
my omni,
then,
and then one more double quote at the end.
you mean that one?
Yeah, and allegedly that will decode. No, it didn't.
No, 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 no. It is not how it works.
Yeah.
I no, it is.
Interesting. Well,
It is bad character. It is clearly says that it should not be
the
here.
dash.
If we go here,
Interesting. Well, maybe we should include that note in the docs to be like, hey, don't include a dash in your in your secrets variable name.
I don't know. No, no, no. It is something wrong with that.
With the value, you say.
I think it is something wrong with the value. I don't
Could
know
be.
what exactly. But
But
again, so what I'm going to do, I'm going to remove it.
sure.
Okay. Shit. That is. Delete
And just
and then
recreate.
start from scratch with
Yeah.
different password. Let's go to documentation how to delete it. Resize, delete your database cluster.
Update the spec to say is deleted true, and then it'll take itself to.
Yes, it is. How we do that?
All right.
Budget. It is not.
So then if you just update the value and then remove is deleted, it'll recreate itself. I mean that makes sense with how Kubernetes kind of stores and keeps
Okay.
application state up to date, but interesting.
Oh, we can see it here.
In K9s, yeah.
It should be. Yeah, we don't have it anymore. So what I'm going to do is install on Kubernetes.
Sure. And we are slightly over time.
We out of time already.
We are slightly over time, but I think I do want to see if we're about to.
Okay, so let's go with
the tried and true documentation password.
Yes, exactly. Yeah, it should be not difficult. Right. Oh my God, why is it V? And so what I'm going to do, I'm going to put the password. I would know that it should work because it is from Google documentation.
Right.
And then
don't we have to remove the is deleted tag? No.
That's it. Let's see. And we're gonna see here.
Oh yeah, no, we're good.
It will take some time, hopefully not too much, but again, it is kind of fun.
Yeah, this is interesting.
Yeah. I believe people lost patience and probably
That's all right. We have the Kubernetes and the GKE and Alloy super fans
that's right, yes.
online.
But what we're going to, it is going to be deployed here, and we are going to connect to Gemma
Yeah,
database.
I'm excited to see this comparative time and see how it goes.
Oh, oh, not yet. It is still deploying.
2 out of 3.
Yeah. We need one more, and then we can start working on it.
Perfect. There it is.
Almost. Yeah. Okay. So now let's try to connect. Okay. It is change me 1 to 3, I believe.
It was.
Connect. Right. Let's do that. Here we go.
Perfect.
Create database demo.
Perfect.
Right, and I believe all right, let's now we need to go back
To
to
the last
documentation. The
documentation.
documentation, yes, we need to install change some parameters.
Right. I remember there's the enable ML integration and enable ML agent.
Yes, we are not going to repeat the same mistake, so
Yeah.
hopefully let's run that command.
Yeah.
Okay. Then we can register model right away. I think I have saved somewhere the previous run. Okay, call, yeah, that one. Oh, actually, what we can do, we are going to replace. Oh, shit. Why is it?
Oh, in the
Get services. So we're going to use cluster IP. Where is our LLM service? That one.
yeah, okay.
Because we are inside the same cluster right
Yes.
now.
Inter-cluster communication. We want to create the load balancer for sure.
We don't need actually to, for example, load balancer. It is we're using internal cluster load balancer, right?
Absolutely.
Yeah. So let's do that. It is internal, right?
Create the stored
Now,
procedure.
yes, we need now update a parameter for the database. So to do so, we need to connect bin bash, I think.
Yeah, to the pod running the Alloy instance.
Expert DB pod, right? What?
And I wonder, wouldn't we be able to? We're doing this to enable the ML agent property, right?
Yes.
But wouldn't we be able to enable that property with the same like select restart PG conf command we had above?
But we need to change it.
Okay. We need to change
pgconf. I don't think so. We can try, but I don't think so. I think it is has to be in PostgreSconf because it is an agent inside the container.
Right. Fair enough.
We can try, but what I'm having difficulties now is
getting the IP for the pod running.
I don't know why it is giving me hard time right now.
Yeah.
It is not supposed to do so. Let me run and connect AlloyDB Omni here. Stop, start. It is not that one.
IP address.
Yeah, it is. Let me try again. Okay, so yes, cd var lib postgres data, and we need to run echo for one of the parameters.
The parameters. We want to check if the agent is already running. Is that?
No, it is just update the parameters. That one. That one. It is what I want to do is post. Huh. Hold on.
You will need to go a little bit deeper into the.
I don't see anything here.
Didn't we have to create the file last time as well?
No, we didn't.
Are we in the right directory? Data? I thought it was data slash.
It might be not. It could be not. It is.
I can't remember the path.
Where it is.
Varlib PostgreSQL data. We are in varlib PostgreSQL data, right? Oh, apparently you can have Postgres show the config file path.
Yeah, it is.
We'd have to reconnect.
What is
show config underscore file?
Config underscore file. No, it is there.
Oh,
it is completely different. CD.
Weird.
Let's go the data.
Don't we have to exit? No.
Post.
Because we're currently running as the Postgres, like we're inside of Postgres still, right?
Yeah. Right? Should be. Yeah. Oh, no, it's not what we need.
No, I think the grep was just a little bit off, yeah.
It is that one.
Yeah, there we go.
Yeah, it is here. So what we need now, it is stop start.
Yes. Stop, start, run the command, then we're there.
Yeah, hopefully. I don't know. Run and connect. Stop, right?
Yeah. Well, let's start. We could
No, it is start. Where is stop here?
down
Stop.
there. Yeah.
Yeah.
I mean, couldn't we just kill the pod as well and then Kubernetes?
We can probably.
But I guess this is the documented, recommended way.
Yeah. All right.
Excellent. And so now we should be able to call that stored procedure.
Oh, interesting.
Container not found database.
Yeah. Let's try it again from scratch. Yeah.
I'm guessing it like registers that container name somehow when we create the connection the first time.
Yeah. Let's try to run it. The same query, right? Right?
Yep.
What is going on? Oh, sure. Let me remove some extra lines. Oh, it shouldn't be a problem.
It's interesting. Yeah. It did it.
Oh, yeah, of course. It is the same error we did before, right?
Yes. Wrong database.
Okay. Timing.
$431.
That's right.
Can you try something? Oh, it's the same speed. Yeah. Yeah. That's very strange. Okay.
I don't think the problem is where you run it from. I think it's the problem response of the Mandel model itself.
Yeah, fair enough. Okay, well, we've determined the regular response time.
Yeah.
We've ruled out the pod local versus project local, or the cluster local versus project local response time gap myth.
Right. And we didn't rule the most immediate problem, why our password didn't work.
Yes.
Just some probably base 64 output was not right. I vaguely remember I had such problem long time ago, but I don't remember the solution.
Interesting. I can't say I've run into that one before, but it was a fun ride. Thank you for taking us through this, Gleb. And yeah, I hope that we'll be able to bring you back on for another episode, probably next season. And I hope that everybody who's watching joins us again. We have another episode next week. That'll be our second last episode before the end of the year. And it's been a pleasure doing it with you again. For now, it's goodbye from me and Gleb, and we'll see you next week.
Cheers, guys.